In this chapter, we're going to reintroduce you to object-oriented programming and creating classes. And I'm going to start over again to some extent, although I'll move a little bit faster since you've already seen an introduction to this material in Chapter 5. What I want to do in this chapter is cover these subjects in a little more depth than we did earlier. So for this chapter, we're going to build a time class that keeps track of hours, minutes, seconds. And what I want to do in this lesson is talk more about the difference between public and private data members and how those work. So let's go ahead and get started. Open up a DOS window, and when you get that window open, create a file called time.java. In that file, write public class time, open bracket, and then write int hours, minutes, and seconds, and then close it. In a minute, we're going to put an access modifier on that, but let's talk for a minute about the difference between public and private. A public data member is accessible by any program that has access to the class. And really, that means any program at all if the class has been imported correctly, or you can access it through the folder or subdirectory that you're in. In general, having your data members be public is a bad idea because that means they can be set to any legal value for that data type. I'll show you what I mean in just a minute. Whereas if you make your data members private and you only allow access via some type of accessor method like a set method, then you can control what values are put into that data member. To demonstrate how that works, let's make our data members public. And then to be able to create a class, we've also got to have at least one constructor. So we'll create a default constructor that'll just set each data member to 0. Which would be the default value for the integer data type. And that should be enough to get our program to work. So let's save the file, go back to our DOS window, compile it just to make sure there aren't any issues, and there aren't. Now let's create a work file. So we're going to create a work file called chapter 12 part 1.java. You notice I've already got a file here. Let me erase those values and let's start over again. First thing we want to do is declare the object with a constructor, in this case the default constructor, like so. Then, because our data members are public, we can access them directly via assignment statements. So I can write a set of statements like this, which works just fine. And to be honest, there's nothing wrong with that. Let's compile it. It won't do anything when we run it, but we can still make sure it compiles correctly. So we'll write javac chap 12 part 1.java, and then java chap 12 part 1, although it's not going to do anything. Just return. But these values, these data member values, are public, which means that, yes, I can set them to valid hours, minutes, seconds values, but I can also set them to invalid, like the 120,000th hour, or minutes 72, or seconds negative 100. That's not valid data for a time object. But because those are valid values for an integer data type, when the data members are public, then we can set them to whatever we want to set them to. The alternative to that is to make the data members private. So let's minimize this for now. We'll come back to it. Let's change the access modifier to private. Now, the only place where we can modify these values is within the definition of the class. Nowhere outside the class do we have direct access to the data members once they've been declared private. So to verify that, let's go back, recompile our work file. Well, first we have to recompile the class. So let's compile it. Now compile the work file, and then try to run it. Let's make sure we have the right file. Let's save and exit. I have several open at once. There we go. That's probably what the problem is. Don't save. Clear the screen. Let's go back and look at my time definition again. I bet that's where the problem is. Save it. Close it. compile this again, and there we go. I knew there was a problem someplace. I just had too many files open at once. Because I set hours, minutes, and seconds to private, now they have private access, so I can't access them directly in a working program. I have to set them directly inside the class definition. If I want to set those values, then I have to do it via a set method that the user calls directly, rather than direct assignment. And that's really one of the primary concepts of object-oriented programming is encapsulation and data hiding, where we take the data that's stored for our object and hide it and not make it easily accessible, but accessible only through an interface or a set of methods that we define. And that's an important concept in object-oriented programming. So to review, when we want to limit access to the data members of our class, we make the data members private via this access modifier. If for some reason we want to have easy access to the members, then we can make them public, but again, that's frowned upon and generally a bad idea. And it's best to keep your data members private and then write methods, like set methods, to allow access. So that's our review of public versus private. Now we're going to move to the next lesson where we talk about implementing constructors. In this lesson, we're going to see how to create methods that allow you to display the data stored in an object. And we're going to look at two different types of methods. One, a toString method that you'd use primarily with debugging, and then another method which will be just a display method, which would be part of the public interface that any user of the class would use. So let's start out with the toString method. It's a public method because we want the user of the class to be able to access it. We may take it out when we actually publish the class and give it out to final users, but for now we'll include it. So it's a public method. It's going to return a string, and it's called toString. And all it's going to do is it's going to display the state of the object at any particular time. And so what we want to know are just what are the values for the hours, the minutes, and the seconds. And we want that in a fairly readable format. So we're going to write it like this. We're going to write return hours, and then the hours themselves. And then we want to put that on its own line, so we'll put a new line. And then we'll do minutes. And then a new line. And then seconds. And a new line. Actually, we don't need a new line here because that's the last line of the string. And then we close off the body. So that's the toString method. It's going to show us the hours, the minutes, and the seconds with labels for each one of those. So let's save that. And then let's compile. Move the screen first. And it compiles fine. Now let's open up our working program or our test program, part 2. And so you see I've already got the information here to save a little bit of time. The time equals new time, and we set it to 11:23:0. And then to write it out, we're going to write the time toString, and that's how we call the method. So let's save that, compile it, then run it. And there it shows the state of the object after the constructor call. That's the only time we've done anything to the data. So that's how you write toString. Let's go back to the time class. And that's fine for debugging purposes, but we also would want a display method of some type that a user of the class could use. So why don't we make that method name display? We might say display time. We'll just leave it at display for now. We can always change it later if we decide that's not appropriate. So it's going to look similar to our toString method, except we want a different format. Generally, the time is displayed in hours, minutes, seconds. So let's give that a shot. So we have hours plus a colon, plus the minutes, plus a colon, plus the seconds. And this is a very simple method to define. We could modify these in some ways and have 12-hour format, 24-hour format. We'll probably look at that in the exercises. But for now, we'll have just a simple display method. So let's save that. Clear the screen. Let's compile the class again. Although I can't imagine whether there'd be any problems with such a simple method. Now let's go back to our working program and let's change this from toString to display. Save the file. Compile it. I've already got it here somewhere, so let's find it. There it is. And then run. And there's our display time. The only problem I see with that is that generally the format for displaying the time should be 2-digit hours, 2-digit minutes, 2-digit seconds. Notice that the seconds are displayed as 1 digit because it's 0. If the time had been 9:23, it also would have been displayed with 1 digit. So we need to go back and rethink how our display method works. So let's bring the class code back up. So what I want to do is I want to create a string for each one of the data members, hours, minutes, and seconds, so that we can add a 0 onto it if it's less than 10. So what I'm going to do is I'm going to create 3 variables. Hours, mins, or HRS, mins, and SECS for seconds. And then we're going to say if hours is less than 10, hours is equal to hours plus a 0. Notice that I do that in a string. Else, hours is equal to hours plus, and then we concatenate an empty string. We have to do that because you can't just directly assign an integer, hours, to a string variable, HRS. We have to kind of turn the integer into a string by concatenating the empty string. We saw that earlier in the course when we were working with chars. It's the same situation. So we'll do the same thing for minutes. Mins equal to minutes plus empty string, and then we'll do the same thing for seconds. And then concatenate empty string. And there we go. I think I have 2 closings. I do. There we go. I think that's it. So let's save the file. Compile it again. This is our time class. Whoops, there it is right there. Okay. And we forgot to return it. So let's go back. As always, I got caught up in the process and forgot the final result. There we go. Save the file. Compile it again. Compiles just fine. Now let's find our working program, recompile it, and run it. So there you see that now the seconds are displayed in a 2-digit format. Let's try one more piece of that. Let's change the hours to 9. Let's just change the minutes to 1. Just to verify that it works for all cases. Compile and run. Oops. You see the mistake we made. We concatenated on the end instead of on the beginning. So let's go back and fix that. It's no problem. Just have to reverse it. Take the string 0 and add the hours. Do the same thing for minutes. And then do the same thing for seconds. Save the file. Compile again. Let's clear the screen. Now let's compile. There's our working program. There we go. 09, 01, 00. So to recap, what we've learned how to do is create 2 methods for displaying the data. One method, toString, is used primarily as a debugging tool, and we'll look at that in more detail later. And then the second is a more general display method, actually named display, that we could use to let the user of our class display the time from one of their time objects. Now we're ready to move to the next lesson, where we're going to talk more about the accessor methods, or the setters and the getters, that we use to return pieces of data from a class or to set either a whole time or parts of a time as necessary. And we'll see that in the next lesson. Now we're ready to do something useful with the class. So far all we've been able to do is set pieces of the time or parts of a time or all of the time and then display what we've set. Now we want to be able to use the class to do something. So what we're going to do is we're going to write an increment method that allows us to increment the time and change it. We're going to do that by minutes, so that we'll increment only the minutes part. If we were trying to keep more precise times, we might change seconds instead, but I'm thinking about this class in terms of for an appointment book or something, in which case minutes makes the most sense to increment. So let's write the method. This is a public method because we want complete access to the method. It's a void method though, because we're not going to return any data. We're just going to change the number of minutes that are being stored and perhaps the hours as well. I'll show you what I mean by that in a minute. So the first thing we have to do in this method is to increment the minutes by the amount that we're passing in as an argument. So minutes plus equal amount will add amount number of minutes to the current number of minutes. Then, because the minutes might spill over into the next hour, in other words, we might increment minutes to the point where it's beyond 60, we have to write if minutes is greater than 59. We need to do a couple of things here. First, increment hours by 1, and then subtract 60 from minutes. So we'll do a minus equals, if I can type it in there. There we go. To get rid of that new hour that's in. And that should be all we have to do. So we'll close out the method definition. Let's save the file. Now I need to create a new program to work with. So let's clear the screen. Notepad, chap 12, part 5.java. Public class, chap 12, part 5. Public static void main. String args. Time, the time equals new time, and we'll just say 900. Then we'll display the time. System out, print line, the time dot display. Then we'll increment the time. Let's do it by 1. Then display it again. Then let's increment it by 30. And then display it again. And this time let's increment it by 40 and display it one more time. And that should give us a good feel for seeing if the method works or not. So save the file, compile our test program. So you see what happened. We set the time to 9 o'clock. Then we incremented minutes by 1 to get 9:01. Then we incremented by 30 to get 9:31. And then we incremented by 40 to get 10:11. Now, there's nothing especially clever about this. What I really wanted to point out is that most classes have some reason for existence other than just to keep track of data, although that's really important. So what I wanted to show with this time class was how we could write a method that would actually use the class in some way and modify the data members such that we had to think about what the impact was of our method. That's why I made sure we worked with minutes so that we would knock minutes over into hours and have to modify those. I could have done the same thing with seconds to where seconds would roll over into minutes, but again, I explained why I was working with minutes instead. So that's going to end our overview, our second overview of object-oriented programming. So now we're going to move into the exercises. And our first exercise, we're going to go away from the time class for a minute, and we're going to look at implementing an object-oriented calculator to extend the work we've done with calculators from previous chapters. So that's coming up next. Now we're ready to do something useful with the class. So far all we've been able to do is set pieces of the time or parts of the time or all of the time and then display what we've set. Now we want to be able to use the class to do something. So what we're going to do is we're going to write an increment method that allows us to increment the time and change it. We're going to do that by minutes so that we'll increment only the minutes part. If we were trying to keep more precise times, we might change seconds instead, but I'm thinking about this class in terms of for an appointment book or something, in which case minutes makes the most sense to increment. So let's write the method. This is a public method because we want complete access to the method. It's a void method though because we're not going to return any data. We're just going to change the number of minutes that are being stored and perhaps the hours as well. I'll show you what I mean by that in a minute. So the first thing we have to do in this method is to increment the minutes by the amount that we're passing in as an argument. So minutes plus equal amount will add amount number of minutes to the current number of minutes. Then, because the minutes might spill over into the next hour, in other words, we might increment minutes to the point where it's beyond 60, we have to write if minutes is greater than 59. We need to do a couple of things here. First, increment hours by 1, and then subtract 60 from minutes. So we'll do a minus equals, if I can type it in there. There we go. To get rid of that new hour that's in. And that should be all we have to do. So we'll close out the method definition. Let's save the file. Now I need to create a new program to work with. So let's clear the screen. Notepad, chap 12, part 5.java. Public class, chap 12, part 5. Public static void main. String args. Time dtime equals new time, and we'll just say 900. Then we'll display the time. System out print line dtime.display. Then we'll increment the time. Let's do it by 1. Then display it again. Then let's increment it by 30. And then display it again. And this time let's increment it by 40 and display it one more time. And that should give us a good feel for seeing if the method works or not. So save the file, compile our test program. So you see what happened. We set the time to 9 o'clock. Then we incremented minutes by 1 to get 9:01. Then we incremented by 30 to get 9:31. And then we incremented by 40 to get 10:11. Now, there's nothing especially clever about this. What I really wanted to point out is that most classes have some reason for existence other than just to keep track of data, although that's really important. So what I wanted to show with this time class was how we could write a method that would actually use the class in some way and modify the data members such that we had to think about what the impact was of our method. That's why I made sure we worked with minutes so that we would knock minutes over into hours and have to modify those. I could have done the same thing with seconds to where seconds would roll over into minutes, but again, I explained why I was working with minutes instead. So that's going to end our overview, our second overview of object-oriented programming. So now we're going to move into the exercises. And our first exercise, we're going to go away from the time class for a minute, and we're going to look at implementing an object-oriented calculator to extend the work we've done with calculators from previous chapters. So that's coming up next. In this exercise, we're going to build a simple object-oriented calculator. So let's get started. Open up a DOS window to your Java directory or wherever you enter your Java programs and create the class calc.java. So the first thing you're going to type is public class calc. Then we'll begin by first creating a data member to store a number. We'll work this more like a regular calculator that you use where we're entering a number one at a time. So you enter a number, then if you want to enter another number, you're going to enter an operator, then the second number. Then you hit equals and it returns a value. Well, instead of equals, we're going to use show as a method that returns the result, or will show you whatever the current value of the calculator is. So our data member is number. We'll write one constructor that will take a value in, that's a double, and assign it to number. That will be like typing in the first number in the calculator. Then we're going to write public void add, double in, and it will add in to the number. Then we'll write public void subtract, double in, and it will subtract in from the number. Then we'll write public void mult, double in, and then multiply equal in. And then public void div, double in, and it will divide equal in. And then finally public double show, which will return the current value of number at any time. And that should be all we need for this first simple version. We'll make some enhancements to this as we go through the rest of the course here and there. So let's save the file. Now let's create a working file. I'm going to delete one I was working with, and let's create a new one. Public class chap 12 part 6. Public static void main string args. So calc C is equal to new calc, and we'll put the number 2 in to start with. And we'll just use C. I tell you what, let's not use C. Let's say calc calculator equals new calc 2. Then just to verify that the show method works, we'll call it first. I'm going to copy that so that I can use it to display as we go. So Control C. There we are. And we'll say calculator add 10. And then show the value. Calculator subtract 2.3. Now let's do 2.25. And then show. And then calculator mult 10. It'll be easy to keep up with. And then show the result. And then calculator div 2 and show. Save the file. Come back to our program. Let's clear the screen. Java C, chap 12, part 6.java. Java chap part 6. Let's put the output where we can see it. Right here. So we added 10 to 2 and got 12. We subtracted 2.25 and got 9.75. We multiplied by 10 to get 97.5. And then we divided by 2 to get 48.75. Let's go back and look at our definition again. Quite simple, but what's nice about this is that we can take this class and then plug it in any place we need a calculator and use it as is. So we can use it in a program with a DOS interface. We could use it in a program with a window interface. We could use it in any program at all. And that's the beauty of creating classes. Now this one was quite simple, and I didn't do any sort of gets and sets and all the fancy stuff that you can do with classes. But one of the nice things about object-oriented programming is to be able to take something fairly simple, like a simple calculator like this, but make it even more effective by making it plug and play so that we can put it any place that we want it to go and have it work pretty much as is. And that's the beauty of object-oriented programming. For the next exercise, we're going to go back to the time class and make some extensions to that class. For this second exercise, we're going to extend the time class and add a method equals so that we can compare two time objects. That's something we will want to do probably with some use of the class. So to create an equals method, we start out first, we make it public. It's a Boolean method because we want it to return true or false, and we're going to call it equals. Its argument will be a time object, which we're going to call T1, because we're going to pass in a time object to compare to the current object. Now there's two ways to implement this method. One way would be to compare each part of the time, hours, minutes, seconds, but that doesn't give a good indication. And what we need to do instead is convert each time object into seconds and then compare those two numbers to see if they're the same or not. So to do that, we're going to create two variables. The first one we're going to call t-seconds, and it's going to work with the current object. It's going to convert the hours to seconds, then convert the minutes to seconds, adding it to the hours that have been converted, and then adding the seconds. Then we want to create a second object, which we'll call t1 seconds, and that's going to take t1's hours times 60 times 60, plus t1's minutes times 60, plus t1's seconds. T1 being the parameter or argument that we're passing in. Then all we have to do is compare. If t seconds is equal to t1 seconds, return true, else return false. That should be all we need. So come back to our DOS window, clear the screen, compile the time class first, so that's javac time.java. Then we're ready to build a test program. Here's one I tested earlier. Let's start it over again. So we're going to say time, the time equals new time 900. And then we'll say time, a time equals new time 910. So then to compare them, we can simply say if the time equals a time, system out print line the same time, else system out print line different time. So let's compile this program. Javac chap 12 part 7 .java, and then Java chap 12 part 7 different time as we expected. Let's change it. We'll change that 1 to a 0. Save the program. Come back to our DOS window. Let's clear the screen. Compile again and then run. Oops. Make sure we save the program. Make sure they are indeed the same. Let's go back and look at our code. Make sure we put T1 in. There it is right here. Okay, those are right. Come back to our DOS window. Compile it again. I see the problem. I have two chapters 12 part 7 files open. I'm going to close them both. Open it from scratch. Save it. Compile it from scratch. First, we better make sure we've compiled the time class. That's not the issue, but just to make sure. Now we'll compile our test program again. Chapter 12, part 7.java. And then run it. And we still get different time. Let's go back and look at our program one more time. Checking that hours, T1 minutes plus T1 seconds. Hours. When you have a problem like this, the next thing you're going to do, this is probably a good time to talk about debugging programs, is put a print statement somewhere in your program, and I always write debug in my print statement. And then we're going to print T seconds, and then T1 seconds, like so. Okay, let's save it. Then compile the class. Compile the test program again. Then run the test program. And by doing that, we seem to have fixed the problem, which I can't see what the problem exactly was, which is kind of crazy. So let's take our debug statement out. Save the file. Clear the screen. Compile the class again. Compile the test program again. And now it's working. Sometimes crazy things like that happen. I'm sure it had something to do with having multiple files open at the same time, because I haven't changed anything else in the program. Here's the time class. There's the program itself, and they should be the same time. Let's try one more thing. Let's make it go off a little bit this time. And that's right, they're off by a second. If we went back and put that debug statement in, we'd see that one time is greater by 1 second. So, aside from the mystery error in logic someplace, which was probably nothing to do with our code, but a lot to do with me trying to manage files, you can see how to write a method to compare two objects. Again, what we have to do is we have to get the basis for the comparison correct. And that's why taking everything into seconds makes the most sense for time. For some other object, it might be as well just to look at the constituent parts or compare the data members. But for this particular class, it made more sense to convert the time to seconds and then do the comparison. That wraps up this discussion on object-oriented programming, at least this overview or this second overview. Now we're ready to move to the next chapter where we take object-oriented programming to the next level, so to speak, and look at inheritance, where we can create a class that has many of the same characteristics with another class and yet differs in some way, and we don't have to write a completely separate set of code for the inherited class. We only have to write code that's different between the base class and the inherited class. And we're going to see how to do that in the next chapter.